All right, so this next video, it's the same title as the last two videos. Just replace the trig words with tangent. So we already know this formula because tangent is just sine over cosine. And we already have the identities for sine and cosine. I'm not going to do it right now, but you can. It's a great simplification problem. And it could be a simplification problem that maybe shows on a quiz or a test sometime. I recommend pausing the video, trying to figure out you can get this formula on your own using the formula for sine and using the formula for cosine. But what you'll get at the end of the day is this. The tangent of any angle plus any other angle, and again, I'm going to color code this one. The color coding is the most important, I think. It simplifies down to tangent. Also, I'm going to warn you guys, we've got a fraction. Tangent of the first angle, then same signs, so plus or minus, tangent of the second angle, all divided by 1. Yes, you heard me right. And now it's the opposite sign of tangent the first, tangent the second. And again, it should make sense that it's the same sign on the top and the opposite sign on the bottom, because sine is on the top, which has the same sign. Cosine's on the bottom, which has the opposite. So it's just a little simplification, and you can get to this formula. And now we have all three formulas, we can use them. Doesn't take too many steps to go there, but we won't do it here. Let's do example number 3. As a side note, there's a lot of problems that might ask you for sine, cosine, and tangent of an angle. Remember this. Sometimes you don't need to use the full formula. You can use this instead. Just whatever you found for sine and whatever you found for cosine. But anyway, let's find exactly the following. Just like we've been doing, nothing new. Just a little bit of practice. Tangent of pi over 6 plus pi over 4. Again, if you're feeling like you can use these formulas, no problem. Feel free to pause the video and just work on homework. If you want extra problems, go ahead and watch. If you kind of in the middle, pause the video, try to do these extra problems, then see if we get the right answer. So our formula says that this is tangent of the first plus, it's always going to match the sign on the top, tangent of the second, divided by 1 minus, always the opposite sign of whatever's on the inside, their product. Tangent of the first, tangent of the second. I'm going to double check to make sure I did remember my formula right. And it looks like I did. Great. So now we got to find all this information. So again, our special reference triangles are going to be very useful here, right? The 45, 45, 90 triangle, tangent's 1. This 30, 60, 90 triangle. Again, this is pi over 6. Nope, that's not. This is pi over 6. All right, so tangent will be 1 over root 3 for that one. Tangent's 1 over root 3 plus tangent is 1 divided by 1 minus 1 over root 3 times 1. Now simplifying this might be a little squirrely. A few ways of doing it. I think the easiest way, if you can get past the weirdness of it, is to multiply the top and the bottom by the least common denominator, which in this case is the square root of 3. Now that distributes on the top and it distributes on the bottom, and we get something really nice. The top, well, the first one, it cancels. We just get 1 plus root 3. The bottom, the first one is root 3, and the root 3 cancels in the second one. Now be very careful. I'm getting a little nervous here. I'll definitely be checking my answer on this one. We got some weird stuff happening over here. what do we have? It looks like something cancels, but it doesn't. Right? What is this? This is the square root of 3 plus 1 over the square root of 3 minus 1. You can't cancel or simplify unless there's a common factor. These guys are package deals. So you can't cancel because they are not the same thing. This is as simplified as it gets. So you could box this answer, or you could box this answer. They're both right. I just rewrote it to really show that, okay, they're not the opposites of each other either. So we can't factor a negative out. Let's check our answers on this one. Square root of 3 plus 1 divided by the square root of 3 minus 1, just like so. Is that the same as tangent of pi over 6 plus pi over 4? Don't fret. We're in radians. So make sure your calculator is in Oh, look at that. Wasn't that nice? They are correct. Great. All right. So that's letter A. Do letter B as well. Again, feel free to do this on your own or practice or follow along with me. Tangent of pi over 12. That's not a special angle. That's half of pi over 6. Spoiler alert, in the next section, we come up with a half angle identity and a double angle identity and a reduction formula. 3 different kinds of formulas, but they're all basically the same thing. That's coming up. But here we're going to find this with the difference formula. So again, it might be easier to convert this into degrees, but if you want practice, it's okay. How do we get pi over 12 from the ones we know? Pi over 6, pi over 4, pi over 3. And if you're ever trying to do this directly in radians, I'd recommend writing all 3 of these as divided by 12. Right? That's 2 pi over 12, 3 pi over 12, and 4 pi over 12, because now it's much easier to see how we're going to get 1 pi over 12. Right? It's just this minus that. So if you're ever trying to do these without converting them to degrees, put them in the denominator that we want. So this is the tangent of 4 pi over 12 minus 3 pi over 12. And now, yeah, we can simplify. Okay, so 4 pi over 12 was pi over 3. 3 pi over 12 was pi over 4. I just really like this middle step just to make it a little easier to see what's going on, since radians can be a little bit more confusing. And now we use the formula. Tangent of the first, same sign, minus minus. Tangent of the second, divided by 1 plus, opposite sign here, tangent of the first, tangent of the second. Just like before, tangent of pi over 4 is 1. Tangent of pi over 3, going to be root 3. That's this angle over here. Okay, so square root of 3 is one of these, and 1 is the other. We get square root 3 minus 1 over 1 plus square root 3. Look a little familiar? It should. It's almost the same, but not quite. So that's our answer here. That's pretty much it for this video. Let me know if you have any questions. The next video is a really fun one. We're going to get some practice verifying identities with some of these new formulas. And then I'll have an extra video where I do some homework problems to give you some extra practice if you'd like. Bye-bye.